So we're going to do a small word problem using factoring. And this is a basic finding the area question. If you look at it, it says a rectangular porch has dimensions of x plus 12 and x plus 5 feet. If the area of the porch floor is 120 square feet, what are its length and its width? Now we all know that area is the length times the width, which I wrote here in pencil. I like to underline important things in the word problem. It helps me organize my thoughts. So I'm looking at rectangular. That is important. I know the shape, right? It's going to look something like this. Something like that. And I know the dimensions are x plus 5, x plus 12. We can do something like this and something like that. It doesn't necessarily have to be that way, but it's more than likely like that. Anyway, so I know that the length times the width, whatever it may be, is going to equal 120 because it says the area of the porch is 120. And how do we find the area? Length times width. So we're going to go ahead and write it. The length we're going to say is 12, x plus 12, and the width we're going to say is x plus 5. Because multiplication is commutative, it doesn't matter which one you put first or second. It really doesn't. But when you multiply them, they're going to give you the area, which is 120. Now, we can't find the zeros because it's not equal to 0, so we're going to have to go ahead and multiply this through and use, distributive property or a way of a FOIL in order to break this down and then bring that 120 over. So we're going to begin by, we're going to take this first x and this second parentheses, and we're going to multiply them together. Okay, and then we're going to take the second number here, plus 12x plus 5, and we're going to multiply it by the parentheses, which gives us 120. Okay, now we're going to come here and we're going to use the distributive property, and we're going to multiply this x outside by every term inside the parentheses. X times x gives me x squared. X times 5 gives me 5x. And then 12 times x gives me 12x. And 12 times 5, if you forget, we can write it down here. 12 times 5, carry the 1, 60, will give me 60. Equal to, I'm going to write this in black because that's from the general formula, 120. All right, now we've kind of broken everything apart. If you are familiar with FOIL, you will notice that my first is always the first term. My outer is 5x. My inner terms, 12x. And my last term, 60. So some people like to go ahead and distribute. I like to show where it's coming from. And but it gets you to the FOIL, F-O-I-L. First, the outer ones, the inner, the last. Now, we look at our x squared and we say, is there any other like term here that has an x squared that we could add or subtract to it? And the answer is no. There's nothing else with a power of 2 that has x as the base. Okay, so then we look at the 5x and the 12x. Both have an x. They are like terms, and we add the two. So we're going to go ahead and add the two coefficients, the two numbers in front. 5 plus 12 is 17x. Lastly, do we have a number to add or subtract to 60 on this side of the equation? The answer is no, so we just write 60 equal to 120. Now our goal is to get this to 0 so we can factor out and find out what times what gives me the area. All right, so in order to do that, the only thing that we can do is move this over using the subtraction property of equality, right? That would give us 0, and we get x squared plus 17x. Now, if I like to say this, I think it's easy for my students to understand this. If I have $60 and I owe someone $120, I give them all the money I've got. Guess what? I still owe them $60. And a lot of my students have a very easy time understanding that because, they deal with money all the time just in regular living. So it kind of makes it real for them. But 60 minus 120 would give me negative 60. And obviously 120 minus 120 gives me 0. Now I can factor it because it's equal to 0. And using the 0 property, I can figure out what I can have for x. And from there, figure out my length and my width. So here we go. Do I have a coefficient here that I can factor out of this trinomial? The answer is not really, because it's 1 times x. This is 17, and that's negative 60. There's nothing to factor out. It is what it is. So we're going to go ahead and make our 2 parentheses equal to 0. We start with the first one, x squared, x times x. That's your first, right? Just like it was here, x times x, x squared first. Now, we're going to do negative 60. As we looked at, this is our first one. And for our second term in each parentheses, we have to figure out what times what gives me negative 60. And also, when I add it, gives me positive 17. Okay, so I have to be careful with this one because this is negative. That means one has to be positive and one has to be negative. And when I multiply it, or it has to give me a positive number. So whatever I multiply with the negative, the positive number's got to be bigger so that when I add them, it's going to give me a positive answer. So we can try different combinations. Let's try with a pencil. If I try, let's say, I don't know, negative 3 times 20. Okay, I think I'm going to get lucky with this one, but negative 3 times 20, right? When I multiply them, yes, it meets that requirement. It does give me negative 60. And when I add the two, negative 3 plus 20, I am so lucky today. When I add the two, if I owe $20, if I have $20 and I owe 3, I use my $20 to pay my debt, I still should have $17 left over, right? So this works with both the first and the middle term. I know I'm good to go. And I'm going to write negative 3, positive 20. It really doesn't matter which one you put first or second because when there's a number here in the leading coefficient, then where you place it makes a big difference. But with no number, just a 1, it could be either way. You could have it on the front or on the back. X plus 20, x minus 3 equals 0. Now, what are the answers? Well, we're going to find the zeros. So if this parentheses goes to 0, what does that x have to be? And that's pretty simple to see. 3 take away 3 will give me 0. And 3 plus 20 will give me 23. Okay, but 0 times any number always gives me 0. And the same thing for this one. So x could be 3. And we write it as x minus 3 equals 0. Okay, if I add 3 using addition property of equality to both sides, I get x is equal to 3. That's a possibility. Great. Our next one. So if x is 3, that's 0. This is 23. 0 times 23, 0. We're good to go. Definitely a good thing. Now, x plus 20 equals 0. All right, well, let's get that 0 alone. If it's positive 20, we use subtraction property of equality, negative 20. 20 take away 20, we get x equals negative 20. Now, I have a question. We're talking about the dimensions of a porch. Okay, when we put in negative 20 into this and into this, we're going to get a negative dimension. So you have to be careful with word problems. They have to kind of make sense. We don't have, you don't measure a porch by saying, oh, that's negative 15 or negative 20 feet. You just don't. So this, because we're talking about area, we don't have negative area. So by default, this has to be our x. Now we're not done here yet. We have to take this number and put it into this, right? And we should actually get the answer. So our x equals 3. 3 plus 15 is, well, let's see. We get x plus 15 plus 12, excuse me. X plus 12 equals, sorry, whoops, my bad. 3 plus 12 equals 15. That's one dimension. And then 3 plus 8, I'm getting them from up here, right? 3 plus 8 equals, 3 plus 5, I'm a little messed up here. 3 plus 5 equals 8. So my two dimensions are 15 and 8 of the porch floor, right? And when I multiply them, I should get 120. So I put them into the original ones here. Let me mark them up here. 3 plus 12 equals 15, and 3 plus 5 equals 8. So my dimensions are 15 and 8. And that's how you figure this problem. So factoring, you see a lot of area problems where instead of numbers, you have variables plus or minus to a number. I hope that helps, and I hope you can look at it a few times if you have any questions. And well, that's it for part one of factoring and solving equations by factoring.